Hello, how is everybody? Welcome. Look at that, internal storage, 48 gigs free. Not what we're going to be looking at today. Yes, folks, welcome to Advent of Code 2020 day. What are we on, day 14? Now, I have a very curious question. Is anyone currently watching us on YouTube? uh, because the Googles have been having a little bit of a a little bit of a bad day, shall we say? I believe at one point YouTube was completely down for quite a long time because a lot of my friends with young kids were like, kids are kicking off because YouTube stopped working. The extent to which YouTube is the pandemic lockdown childcare solution cannot be overestimated. So, anyway, welcome. Nice to see you all. Um, or to see a little number 7, which I believe has real people somewhere behind it. So today we are going to be looking at Advent of Code day 14. Now I had a very quick look at this. I've been juggling a whole bunch of other work stuff. Hey Ivan, looks like YouTube is okay now. Well, that's good. It's nice to know that YouTube is back and people can park their children in front of it yet again and let them watch Peppa Pig videos. Okay, let's do the thing. So, we're going to have a look at day 14. Now, today's bonus points. If we get day 14 done, and we don't have any better ideas, I want to go back to day 13, yesterday's, because I think yesterday's solution that we came up with on the stream yesterday, I think that could be made into something really terse, like 2 or 3 lines maybe. I think, if we can get the recursion syntax on that right. So we're going to have a look at that. But let's kick things off today by... Ooh, no, don't. That's what I want. I want a Advent of Code browser window, not a Gmail browser window. Okay, so, oh, I forgot to start recording. Hang on a second. Hello, friends! That was me starting the recording, for those of you who didn't, because YouTube is sometimes keeping the videos and then it drops them, and having recordings of it is nice for people who apparently watch this afterwards, because it's some good quality lockdown entertainment. Right, let's have a look. What do we got? Day 14. Docking data. As your ferry approaches the seaport, the captain asks for your help again. The computer system that runs the port is not compatible with the docking program on the ferry, so the docking parameters aren't being correctly initialized in the docking program's memory. Chaotic Black, 1 a.m. where you live, by which I'm guessing you are gonna be 5 hours west of here, which is, that's, east of Moscow. Novosibirsk? India. Cool. Welcome. All right. It's nice to know that we're getting some global reach going on here. So that would make this, 11 o'clock where you are. So basically, if I go on longer than an hour, you got to stay up past midnight to watch me failing to get the computer to do what I want. So cool. Well, thank you for tuning in. Right. Where were we? So... initialization you discover the Seaport's computer system uses a strange bitmask system in its initialization program. Now, I love bitmasks. I think bitmasks are brilliant. You don't have the correct decoder chip handy. You can emulate it in software. The initialization program can either update the bitmask or write a value to memory. Values and memory addresses are both 36-bit unsigned integers. For example, a line like mem8 equals 11 would write the value 11 to the memory address 8. Either update the bitmask or write a value to memory. The bitmask is always given as a string of 36 bits written with the most significant bit on the left, 2 to the 35 on the left, and 2 to the 0 on the right. Good. The current bit mask is applied to values immediately before they're into memory. 0, 1 overwrites the corresponding bit in the value, while an X leaves the bit in the value what? The current bit mask is applied to the values before they are written to memory. A 0 or 1... What? Overwrites the corresponding bit, while an X leaves the bit in the value unchanged. What? Okay, so how do you have a bit mask with what? what bit is X? I mean, 0 and 1, yeah, fine, but what is this 0, 1, and X? Um, crikey. All right. All right. All right. So, if it's got 1, zeros, and X's in it, it's not a damn bit mask. A bit mask is made of bits. Zeros and ones. That's why we call it a bit mask. Not a weird bit 0, 1, and X mask. True, false, file not found. Exactly. Uh, Program starts by specifying the mask. The mask it specifies, well, 2's bit is over 1, 1, 0, and the maybe monad. The program starts by specifying a bit mask. The mask it specifies will overwrite 2 bits in. So the 2's bit is there, it's overwritten by 0, and the 64's bit is overwritten with 1. The program then, okay, so the program attempts to write a value 11. Jaro wants to talk about quantum, so we got zeros, ones, and presumably the x's here are quantum entangled qubits that have been run through a Hadamard gate, so we don't know what they are yet, but we will eventually when we force the waveform to resolve itself. Program attempts to write the value 11, but the value 11 is gonna be... Okay, alright, maybe this is hey Chris, welcome, how you doing? So you know, Chris, you having trouble with Twitch yesterday. Well, today the whole of YouTube went down. Actually, YouTube went down about 20 minutes after I tweeted about doing Advent of Code on the Amstrad logo system the other day and putting that video up. And I wondered if Amstrad logo was so much the new hotness that it actually crashed YouTube. But I do not think that is actually what happened. So, what do we got here? Because of the mask, the value 73 is written to memory address 8 in. Okay, so 11. So 11 is gonna get. Okay, so the bit mask is actually. Yeah, I see. So anything in the. Yeah. Okay. Then it tries to write 101. Yeah, that's fine. Yeah. Yep. You need the sum of all values left in memory after the initialization program completes. The entire 36-bit address space begins initialized to the value 0 at every address. In the above example, only 2 values are not 0. 101 and 64. Okay. Alright. I think. Get your puzzle input. Yeah, simple. Alright. So, what language should we do today in? C# or JavaScript? We're not doing it in Rockstar. Rockstar does not... Actually, I say Rockstar doesn't have bit manipulation operators. I'm not sure whether this is actually gonna be some bit masking and stuff, but never mind. I think we can figure it out. So, I'm gonna do C# for this one, I think. The bit twiddlers in JavaScript are a little bit unconventional, and we might have to do some gnarly things. So now what's interesting here, let me grab that sample input program. Here is our sample program. So we're expecting that to give us 165. All right, dang, copy that, start. Visual Studio 2019, new project. See that? I invented a jingle there. How about that? Create a new project is going to be a .NET console application. And we are going to plug in console app .NET Core. Yep, next. This is going to be day 14 in the project's GitHub Advent of Code 2020. The solution name is day 14. Okay, create that one. Ooh, look at that. That'll be Visual Studio. Okay, there we go. Nice. Right. Okay, there we go. We got a program. We got some input. Let's do our good old static const string input equals dum dum dum. Okay, so now the fun part here, the part that's interesting, is that this bit mask here, this thing that's full of X's and thingies and zeros and whatnots, so we need to build a very simple parser. We need something, first it's going to look at the line, and any line that starts with mask, actually we can split the line on space equals space. That'll give us the 2 tokens. Then we want to have a look at the first token. If the first token is mask, we do one set of operations. Otherwise, we do another set of operations. Now, I'm wondering whether we might want to implement some kind of testing with the way that we're going to be doing this today. And I think... yeah, we do. Just to get the arithmetic right around the way that mask manipulation is going to work. So I'm going to plug in a new project here, and I'm going to do a NUnit test project, .NET Core, yep, that's fine. Next on that one, NUnit test project, day 14 tests. Okay, resolve all the things. That is nice. Let me enable ncrunch, which is going to sit and it's going to just cram through our tests in parallel all the time. And I'm going to drop that back in and sling that in down here, which is kind of nice. Hey, Gianluca, don't I like regexes? I love regexes. I absolutely love it. I think a regular expression, a well-crafted regular expression, is a wonderful, wonderful thing. So let me just check. That should be fine. That should be monitoring one test, no test. That's right. Let's go. There we go. So this is my little ncrunch thing down here. It's going to show me all the tests we got. If I break a test, so I go in here and I say public void broken test, and I say, let me just install Shoodly because I like Shoodly. Day 14 tests, install Shoodly. Cool. Right, there's that lot, and now I say 5.shouldbe6, and that is going to fail. And it fails immediately. Bang, red light straight away. So, okay, we got some tests in here. Now, what I want to do is I'm just going to kind of figure out this whole kind of weirdo bitmasky thing here. Because let's come up with a couple of very, very simple test scenarios. So, the way that these bitmask systems work is the mask will overwrite, so anything in the mask that is a digit will overwrite that digit. So if there's a 0 in the mask, the result is always zeroed. If there's a 1 in the mask, the result is always 1'd. And if there is an X in the mask, hey, no worries, Chris. Catch you later. So yeah, 0 in the mask, the result will always be 0. 1 in the mask, the result will always be 1. Otherwise, it'll be whatever the input was. So what we want to do is have a look. Latency is 2 seconds, but their uptime today is maybe got a 9 in it. So, all right. So let's just plug in a test case here. So what I want to do is I'm going to set a test case that says, so the input is, they've said in that one, the value is 11 and the output is 73. Input is 11, output is 73, and the mask for that is this thing here. So that's fine. So public void test mask, and this is going to take int or longs or 36 bits means we can't do it with ints, because ints in .NET have 32 bits. So we're going to say long input, long output, string mask. And at this point, we want to now, quite often, as I've said a couple of times on the stream, when I'm testing stuff, what I do is I write the code I wish worked, and then I work out how to make it work. So masker, masker.apply mask input, and I expect that to be the output. Okay, boom. We should have a failing test immediately because it can't even compile the thing, so it doesn't know that it's there. So I'm going to go over into my program.cs. I'm going to drop a new thing in here, class masker, and let's move that into its own file. Okay, that's nice. And now that I can add a reference, I need to make it public because otherwise you can't see it. Okay, back over to the test. Reference day 14. Okay, apply mask, no such method found. Create method. String mask in la what? Okay. That's interesting. Yeah, I don't know either. What is in? The in keyword causes arguments to be passed by reference. It makes the formal parameter an alias, which must be a variable. In other words, any operation on the parameter is made on the argument. All right, so, okay, so very, very brief. Just going to take a moment out of this, bring up a new terminal here. I just want to play around with that thing a second. I've just found something new, and I'm going to do a tiny little experiment to verify my own understanding of it. CD projects, CD throwaway, which is spelt without a W because I'm a sucker for an 8-letter word. .NET new console in params. So I'm just going to do a little experiment here to verify my understanding of what I think that documentation is referring to. CD in param. So Jara says it means you can't change it. I think it means if you change it, it'll apply globally because it's been passed in as a reference parameter. So let's have a look and see what we get. So we've got a program.cs here. I think if I create a static void mutate in int x, x plus equals 5, and I think if I come over and say int x equals 2, mutate x, that's weird. Why can that method not be resolved? X. That's what we're trying to find out, Gianluca. We're trying to see is in an alternative to that or what. So that's fine. That's fine. That's fine. Let me do a .NET run, see what's complaining there. Cannot assign a variable in int because it is a read-only variable. Interesting. So okay, so that's passing x by reference, but it cannot be modified. Whereas x here should be. Is that gonna top level statement? What have I done wrong here? Yeah, that's fine. That's fine. That's fine. That's fine. Interesting little diversion here. Let's just see what we got. Identifier expected in ref x plus equals. Yeah, it looks like it in ref. Damn, that should be ref int x is what that should be. That's still complaining. Why is that still complaining? The name X does not exist. You ever have those moments? Hello, Archery Luna. How are you doing? I probably mean int ref X, don't I? Yeah, there we go. Is that? No, it's still saying X doesn't exist. Now that's still saying X doesn't exist. Curious. Welcome to the stream. We are looking at C# and something that has worked for the last 15 years suddenly not working and not really being able to figure out why. So, what? Yeah. Okay, it's just on. So there's the wonderful C# plugin thing for Visual Studio Code that just once in a while int ref x should now be able to do. So if we do that now, identifier expected. No, let's go with ref int x. Either way, I'm going to go back to Advent of Code in a second. Argument 1 must be passed with the ref keyword, so that can do that. And that can do that, and that can do that. There we go. Okay, so what we have just determined with our... No. We're just playing around with something. So ReSharper dropped in a language keyword I'd never seen before. And when that happens, I kind of park what I'm doing and I go and play around. So what we've determined is... So ref in .NET is old. We pass ref, and this x equals x plus 2. That modifies the global x here. So we can have some int global var... or let's call it G, so ref G. So passing in ref, that passes by reference, but it's mutable. We can modify it. If we pass it as an in parameter here, that passes it by reference, but read-only. Cannot assign to variable in int because it is a read-only. So we have just determined through a little bit of tangential experimentation what this in long input thing here actually means. Right, let's get back to work. So we've got a well, ReSharper just loves... actually, I love the way ReSharper suggests new language features, because for me and for a lot of other devs, it's often a way you find things you didn't know were there, is that ReSharper pops up and goes, hey, you can do this now. And you're like, oh, that's interesting. Like we just did with the in long input. So anyway, that's fine. Now what we need to do is this mask of ours, we need to split that into two masks, because the basically, if you look at the bitwise operation that's happening here in the assignment, the ones in the mask, or the ones in the mask, always come out as a 1. So anything with a 1, that is going to form a mask that does a bitwise OR, and the zeros, those are going to be a bitwise AND, because we always want the output to be 0 whatever we get to it. So I think we can split this into... So the to-do thing we want to do here is split the mask into a mask of 1s and a mask of 0s. Then we want to do a base 2 parse on each mask to get a... Now we're going to need to go for a 64-bit int here, because it's 36 bits in the mask and 32 bits is the default in .NET. And then we are going to need to, after we've done a base 2 parse, do a bitwise OR with the 1s and a bitwise AND with the 0s, return the result. So, first thing we got to do here is the so var or mask equals mask.replace. So at this point, I want to do a so the mask of ones is going to be the or, so we want to keep the ones and everything else should become a 0. x0, yep. Var and mask equals mask.replace. So this one, x's become ones. So then, actually, I'm going to make these so all mask string and mask string, because we now want to say var or mask equals, now you can't do an int32.parse, but convert.toInt64 will take a numeric base, I believe. One of the overloads to it should, there we go, format provider, int from base, that's what we want. So convert.toInt64 or mask string 2, that should give us a 64-bit integer representing that bit mask pattern. Hey Tess, hello, nice to see you. How you doing? Welcome to the internet. Hello Animesh, nice to see you too. Var and mask string equals convert.toInt64 and mask string 2. So that's fun. That's gonna be just and mask there, and then the is it expensive to pass along by value? You know, it's like a lot of things. Hey Lars, how you doing? Hey Y4NGJH, good to see you, man. Welcome, or woman, I don't know, with a name like that. Welcome. Is it expensive? Well, you know, nothing in computing is expensive unless you're doing it a couple of billion times a second and you're paying for your CPU cycles. That's the interesting thing with all these little optimizations is nobody, you know, when you go out to create a new platform or a new language, nobody says from day one, oh, we need the ability to pass integers by reference, because there's always this balance between a new language being small enough that people will actually learn it and adopt it, and comprehensive enough that it includes things like passing by reference, passing by read-only reference, passing by value, passing value by reference, all these kinds of things. So what I'm guessing is that, you know, as a platform like .NET gets consolidated over many, many years and used for all kinds of things, people start going, hey, this thing here is slow. And one of the things that they wanted to do with .NET Core was to win benchmarks. And there was apparently, this is apocryphal, but I think I've heard it from 2 or 3 people. There was a meeting at Microsoft where when they were building Kestrel, which was the .NET Core, the ASP.NET web server for Linux, they called the team in and went, look, we want to be in the top 10 of these really, really fast things. Go and make it happen. And so they started putting all of these, you know, really interesting optimizations in. What's the project? We're doing Advent of Code, Advent of Code Day 14. If you don't know about Advent of Code, it is at adventofcode.com, and it's little programming puzzles every day. And today we are doing some interesting, gnarly stuff using bit masks, which aren't really masks because they got X's in them, and X is not a bit where I come from. 0, 1, or file not found. But we've, I think, worked out how we're going to do it. So we've got an OR mask, we got an AND mask, we want that. And then we are going to say, so our input is a long. So result is now going to be var result equals the CLR is not on the same tier of speed as languages like C++ or Rust, but it's fast. It's also harder to shoot yourself in the foot. And, you know, the other thing about the CLR is you can have unsafe code. And now in the latest incarnations, they've got spans of T, which are like direct chunks of memory mapped I/O. So those are on a par with native performance, but you have kind of the bounds checking. Like, this is your array and you can do whatever you want with it directly, you know, blitzing in and out of memory and stuff. So result is gonna be the input, bitwise OR with the OR mask, bitwise AND with the AND mask, return result. So And that's going to blow up because that needs to return a long. That's nice. That's going to bring that back. We've got a failing test. Why have we got a failing test? Because... so if you see, this is very, very small, and it's behind my head. Let me drop this in over here where you can all see the test coverage unwinding as we're cranking through the code here. So I got this test mask here. It says should be 73, but was 11. That's interesting. What was the... So I'm putting 11 in with that mask there, and the output I should be getting there is 73. So let's crunch through the numbers. No, I've pasted the wrong thing because I'm special. The mask is the thing with all the X's in it. Bang, look at that. It went green. We know it worked. And it went green kind of as we pasted it. I hadn't even saved the file yet. So... Right, so there's that one's working. So let's look at another example. Another example there. Program tries to, because the mask value is 73, then the program tries to write 101. This time the mask has no effect, so there is our mask. We're going to drop in another test case here. Test case 101. 101, and again the same mask we had. Okay, good, still green. Finally tries to write 0 to address 8, and we're expecting 64. So same deal with the mask. Drop that in a tiny bit there, and we want a test case of, what was it? 0, 64, and that thing there. Alright, so I'm pretty confident that the bitmask logic that we've got there works on 36-bit masks, and it is doing the right thing. So now I want to go back to our Advent of Code brief. So we need the sum of all the values left in memory after the initialization program completes. So we got the masking logic, that's all right. Now we need to go back and actually look at our program. So crunching this thing back around. Can you teach maths? I don't know, probably, but I'm not a maths teacher, put it that way. I have no formal teaching experience in mathematics. I tend to teach people how to do computer programming. But I like maths, so why do you ask, Animesh? What brings you here to the YouTube stream to ask if I teach mathematics? How many solved yesterdays without cheating? I did not cheat yesterday. I solved it by figuring it out. I did not Google the Chinese remainder theorem until this afternoon. And I've got video evidence of that happening, me banging my head against a wall for a better part of 2 hours until, with a little bit of help from the folks on the stream, but that's not cheating because they didn't actually give away the spoilers, we got a solution that we actually worked out together from first principles. So there, right. Let's go back over into our program here. So, first of all, var lines equals input dot split on. So first of all, I'm just going to do the Advent of Code shuffle. Replace /r's with that dot split on /n because we want the new lines on that. Dot select I goes to line dot trim. Okay, that'll give us clean input. Learning is never cheating. But copying and pasting algorithms from a web page without really understanding why the algorithm works the way it does is, I don't know. I mean, the whole idea of cheating at something, the whole idea of cheating at something like Advent of Code, you know, if you're trying to win, then best of luck to you, but it means getting up at 5 o'clock in the morning if you're in the UK, so I'm not playing to win. I'm optimizing for fun, is what I'm doing. So we got a bunch of lines, and then what we want to do for each of those, we need a computer here. So our computer has a whole bunch of memory addresses, and each one of those is going to be a... let me have a look at my input here in the Advent of Code name. How big is my computer? I don't see any memory addresses in there that are long. So we got a 44,000, we got a 62,000. So I'm going to need a... No, it's not 36 bits of address space. That'll comfortably fit in a 32-bit integer. Actually, maybe that'll fit. We got a 59,000. I think... Okay, I'm going to go out on a limb here, and I'm going to say that the address space of the virtual computer that we are putting together is going to be less than 65535, which happens to be an unsigned 16-bit integer. Yeah, Int32 works. I was just curious to see whether we could do something different with it to learn a little bit more about the data types we got. But Int32 will be fine. So Eric says for part 1, Int32 works. I love it when people do that. It's like, all right, well, we'll see what happens with that. So var memory equals new dictionary of int and long, because this is basically our computer's addressable memory bank. Every single element of that is going to be... Now, we could allocate that as a big fat array, because a dictionary that's addressed by integer is kind of the same as a sparse array that doesn't have very many things in it. I'm going to go with dictionary for now, just because it'll make the syntax a little bit cleaner, I think. So then we want to say for each var line in line switch tokens, var tokens equals line dot split on that switch. Now at this point we've got a if tokens 0 equals mask. We could switch on this. This is going to match, so these are just going to fall through into the default case there. So if token 0 equals mask, now we need at that point to, we want a mask in here as well. String mask is going to be there. Token mask equals tokens 1. Yep, okay, so that's all good. So if we update the mask, else, if token 0 equals anything else, we want to value equals, so this will be the long value equals int64.parse, the second part of the instruction. So that's chopping this number here out of the end. That's going to be tokens 1. Yep. Does anyone know if there's a way in .NET that we can split strings into a named tuple? Split string into named tuple. Is it possible for string split to return tuple? If you use C# you can use tuple deconstruction. What? No, that is... No, the answer I want... Yeah, mask is token 0. So we got that already. Mask is tokens Pablo. So the mask we want is this thing here. We're going to split the line. That's going to be token 0. That's going to be tokens 1. So we split on space equals space. And if the first token is the word mask, then we want to capture that pattern of x's, zeros, and ones and put that in the string, which is our mask value that we are applying. So long value equals that. Long value to right equals masker dot apply mask. And that is going to apply the current mask to the current value. That's cool. It's code review. It's the nice thing about it. Possible use of unsigned value. So that mask is going to start out initialized to string.empty.paddWrite. We're going to pad it to 36, and we're going to pad it with X. So we get a full bank of X's for free, which is kind of fun, and that can now be a var. Okay. Otherwise, that equals that, that equals that. We need to extract the digit from this chunk of stuff here, which we could do with a regular expression, or we could just do with a string replace, or we could do by, so that's the long value equals int64. We need to parse out the address here. So int memory address equals int32.parse regex.replace. I'm going to do this a bit dirty. I'm just going to strip out anything that's not a digit from the first part of that. So the input that we've got here is going to be tokens 0, and we are going to split out anything which is not in the range 0 to 9. And we're going to replace it with nothing. Come back, that's right. Let me just make that a tiny bit. There we go. And move that off to there. Tell you what, if I anchor that to the bottom of that window, like that, and bring that in down there, that should give us a little more room to, there we go, now we can see the code. That's nice, and make that a tiny bit bigger. So Python32.parse regex.replace, yeah, that's fine. Tokens, that replaced with empty string. Input pattern evaluator, yeah, input pattern replacement, that's the one that we want. That should be fine. And then, so that's going to mask that, and then we are just going to say memory address equals value to write. Okay, grab that lot, crunch it. And then finally the assignment says you need the sum of all values left in memory after the initialization program completes. Can we do string slicing? /d is more compact than 0 to 9. Yeah, it is. So we could do a and if /d is that, so we can actually say replace any non-digit character. So put a literal quote around that. So if /d means digits, /big D means not digits. So we want to find anything which is not digits and get rid of it. So that should give us what we want out of that. Those can all be vars because we can infer the types from the operations that we're doing here. Can you do a slice? Let's have a look, actually. That might be a string slice in .NET. I don't know. I know JavaScript can. We've got string.substring starts. The difficulty with doing a slice on it is that we don't know whether the number we want here is going to be a 2, 3, 4, 5-digit number. And the -1 syntax test there, yeah, a way to do that is to go in and get string length and subtract 1 from it, and it's a probably slightly faster way of doing it than what we've got. But let's see if what we got is going to work. So they then want the sum of all values left in memory after it completes. So our last thing, that's going to go through every line, that's going to do all that, and then we're going to go sum equals memory.values.sum, console.writeLine sum, done, boom, right, let's see what we get. And that ran, there it is, 165. So the question is, does that satisfy the requirement for the first part of it? 165. All right, so this is the point where we look at the code, we take a moment and go, should we write some more tests? And then we remember that this is Advent of Code. We are optimizing for fun, and our deployment to production strategy here is what the kids call YOLO. So let's grab my input, which is here. Save as D projects. GitHub, Advent of Code, day 14, input.txt, Save that, and I'm just going to jump in, and instead of that thing there, we're going to say var lines equals file.read all text input.txt. Replace, select, that's fine, that's nice. Input.txt, copy to output directory always. Boom! See what we get. Input string was not in the correct format. Why not? Because our tokens here is... What have I forgotten to do, kids? The same thing that I forget to do probably every 2 or 3 days. String split options dot remove empty entries, because there are empty lines in the Advent of Code input. It says that's the answer. Let's see if that's the answer. Back over here. 1, 2, 3. Boom. Hit it. We are 1 gold star closer to saving our vacation. Continue to part 2. A version 2 decoder chip. Seaport's computer system must be used in version 2. Version 2 doesn't modify the values being written at all. It's set as a memory address decoder. Immediately before a value is written to memory, each bit in the bit mask modifies the corresponding bit of the memory address. Ha 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 ha. If the bit mask bit is 0, the corresponding memory address is unchanged. If the bit mask bit is 1, the corresponding memory address bit is overwritten with 1. So, yep, that's fine. And a floating bit is not connected to anything. All floating bits will take on all possible values, potentially causing many memory addresses to be written to at once. Somebody mentioned quantum earlier. Okay. Well, this looks like a lot of fun. So, yep, that results in a, okay, mask there has 3 floating bits. That's fine, that's fine, that's fine, that's fine. Ah, easy. Easy. Probably. Right, so what we got to do is, for any given mask here, I have done a little Q sharp. I'm not doing this in Q sharp. All right, so we now have a new thing where we need to give it a memory address and a mask, and it's going to give us back a collection of addresses that we actually need to write to. So let's jump back over here. Now our masker here, public static IEnumerable of long. Yes, please get the system.collections.generic. That's fine. So we need a thing now that this is called, I'm going to call it fuzz mask, because it's taking input, it's generating a range of possible outputs. String mask in a long address. Okay, so it doesn't... Okay, version 2 doesn't modify the values at all. Instead, it modifies the bits of the destination address. So the values are going to feed through raw, unchanged, but the address is going to get mangled there. So the bit is 0, bit is 1, that's fine. So what we are expecting here is, okay, I'm just going to throw in a return... Okay, so this thing is returning an IEnumerable, which means we can yield things from it. So we don't need to know in advance how long any of the stuff we're working with is. Iterators cannot have ref in or out parameters. Okay, somewhere in the internal plumbing of C# then, there is a weird little quirk which says that if you're yielding from an enumerable, you can't have in parameters, but that doesn't matter. So I'm going to go back over to my tests here. Now, What I'm expecting here is something akin to, so let's just figure this thing out from the very, very simple principles. So if our memory address is going to be 0 and our mask is 0, we are expecting our output to be, so what were the rules we had there? Bit mask bit is 0, the corresponding memory address bit is unchanged. So if that's fine, that's one of our test cases. We've got another test case. If that's a 1, it is overwritten with 1. So that is a 1, that is a 1. We are expecting to get back the value 1. And if the test case pattern here is an X, we are expecting to get back a 0 and a 1 because the bit is going to flow. Let me show you what the function syntax for this thing. Public void test fuzzes. And this is going to take a long input string mask and a array of that'll need to be new longs of that. There's that, okay, and long on that one is gonna be the addresses that we are expecting this thing to yield. So now we're going to say var results equals, so what's an interesting way of doing this? For each var address in so hang on, we got this thing is an enumerable, so var result equals masker dot fuzz mask, and this is going to take the mask and it is going to take the input, and that I'm going to just go to list on it, and I'm going to say result dot should. What's the correct comparison I want here? Should equal. Are you yielding 1 bit at a time? No, what I was going to do is yield 1 result at a time. So let's have a look at how this is going to work. So if the fuzz function is going to generate 4 different memory addresses, I'll yield 1, 2, 3, 4, and then I'll break, I think, but I'm not 100% convinced yet that's going to be the best way of doing this. Yeah, so one of them means use value from input, the other one means always overwrite, but that's fine. So the test cases I've got here are, actually I should throw in another one here. So this should be, so a 1 there means do that, and a 1 there means, so if that's a 1, that should always return a 1, because the 1 should always overwrite. And finally, I want to plug in another one here. That should fuzz that. Now, the reason why I'm pausing here is I'm just checking what the syntax is to assert that one collection of integers is exactly equivalent to another. Well, it's not. It's a set. I need to assert that 2 sets are the same. And I cannot remember the syntax to do that. Resert dot should all be, should be, should be, should be, should be, should not be, should be same type as. Okay, there's a simple way of doing this. Let me just do a really, really simple comparison on it and see what we get out of this. I don't think it's going to work, but the error message might tell me what I got wrong. Yes, that did indeed fail. Yeah, exactly. So I'm going to do, so this is me fuzzing a single bit, then I'm going to do 2 bits, then I'm going to do 3 bits, and at that point I will probably, should be that, but should be a, so actually if I do a .2 array on that, and that should now maybe give us a, alright, yeah, no, that's right, we haven't implemented the function yet. That's doing a yield break. So, right. So to fuzz the mask, what are we doing in here? String mask, long address. So I'm going to start at yeah, this does get rather entertaining, doesn't it? So what I'm thinking here is uh uh du- 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 uh, um we want to look at this just again, it feels like a solution that's going to lend itself to some recursion, and we can have recursive iterators, which is quite nice because we can have a for each with a bunch of yields inside it. So what we want to do is let's start with the simplest possible example, which is we are going to look at the last bit of that, or the first bit of the mask, last bit of the mask. Let's look at the first bit of the mask. Switch mask 0. Go bit by bit and shift. Will that give us all the combinations we need? Because what I'm trying to sort of figure out here is, right, it's paper time! Because my brain has just got to the point where I can't do this by staring at a screen right now. So let me just grab a couple of bits of scrap out of here. That'll do. Right, so show me the paper. Boom, there we go. Look at that. So what we have got is say we've got a number. So our thing, come back. There we go. That's nice. So input is, say, let's do this, look at 4 bits for now. 0, 1, 0, 1. Our mask is x, x, 1, 0. So, if we start with the... Actually, let's start with an even simpler case than that. So, input is 1. Our mask is x. That means that we need that mask x. So for this one, we are going to yield, if that's an x, we're going to yield a 0 and a 1. So that's a 0 and a 1 for that one. And that gets completely ignored because we don't use it. If we plug on another one here, so that's a 1. That's a 0. What was it? A 0 preserves the input value. So at that point, we need to output a 1, 0 and a 1, 1. If we plug in another one here, which is a 1 always overwrites whatever was in it. So that's a 1, that's a 0. So what we need is a... yeah, for XOX we get, yeah, so the fuzz bits are 0, 0, 0, 1, 1, 0, 1, 1. So the number of fuzz things we get will be 2 to the count of x's in the mask that we're looking at. So if we got a single x, we're expecting 2 masks. If we got 2 x's, we're expecting 4 masks. If we got 3 x's, we're expecting 8 different masks to come out of it. But what we want to do is... So let's start with the... if the length of the mask equals 1, this is easy. Switch on mask case x, yield return 0, yield return 1. Still showing paper, thank you. Show me the code, yep. So, I'm actually seriously thinking if there's a way, if there's a way of getting it so when I start typing again, OBS knows that I'm back on the computer and switches everything across, because I get that wrong every time. So if that's that, then break. Case 0, so if the mask is a letter 0, then what do we say? 0 always preserves the input, doesn't it? So this will be return address. Now this will be address bitwise OR of 1, because we just want the last digit, and that'll be a yield. And if we could spell yield, that would help a lot. Case not that, and case 1 always overwrites with 1, doesn't it? Break statement is I wish that yield return would do the right thing in an iterator syntax like that. So there's that, that's that, and we've got tests passing except for that one. Should be 0 but was 1. What's the difference there? Let me take those 2 test cases out. These are our 4 test scenarios for a single bit, right? So, actually no, sorry, those are our scenarios for a single bit. And it's possible that they're just not working because it's comparing things out of order. No, they are not. So we have a failing test here. Our fuzzer says that in this scenario here, 1, 0 to 0, that should be returning 1, doesn't it? Because a 0 preserves its input. So the error there is with the test case. So the problem now is that the 0, 0, 0, yeah, 0, 0, 0 is given back a 1. Why is that given back a 1? Because that needs to be a bitwise AND, because it preserves the input. So 0s comes out as 0s and 1 comes out as 1s. Yeah, okay, so that's cool. So if mask length equals 1, return that lot, and no, that's not what we want to do here. Otherwise, we need to shift address by 1 bit, chop 1 character off the mask, and round and round and round we go. I'm going to one-line these so it uses the space on the video stream a little more efficiently. There we go, that's nice. So if mask length equals 1, else for each hey, Natalie, welcome to the stream, friend. How are you? Else for each var fuzz in recursion is baking my noodle yet again. So we are gonna want to plug into this. Right. Otherwise, what we want to do is we want to take the mask.substring 1. That gives us our degenerate case there. Address, we are gonna, so which way around is this? The address we want to, they're bit shifting in different directions. Ugh. Yeah, I'm alright. I'm doing that thing again where I'm trying to do Advent of Code on a live stream and my brain is not entirely cooperating. We can do iteration since we can find the patterns for x's. So I'm not quite sure how to approach this as an iterative solution. Mask X, that's fine, that's fine, that's fine, that's fine. So all we need to do is kind of like, it's almost like a MapReduce kind of a thing. We're going to end up with a load of things that we then need to crunch back down and turn it into a single list of solutions on the other side of it. So our string manipulation, yeah. That would also work. It's not quite so kind of computery, I guess. Um, but there is an option where we just actually, yeah, we could just there is an option where we just go along and fuzz all the things, right? Uh, so Tessa's example, we find three x's, then the three x's will be the digits in the numbers 0 to 7. Um, hang on, let me think for a second. Is there another way of doing this that just allows us to look at every character all the way along the mask? Yeah, yeah. Yeah, I understand that thing. What I'm trying to figure out is the way of coming up with something that'll, because if there's a lot of, like, if there were 36 X's in the thing, that would be generating 2 to the 36 possible memory addresses that we need to think about. So that'll work for a single length mask. Let me think about a mask here. So if we got a mask of length 2, so if our mask here was XX, we would want to return a single, so that one would yield a 0 and a 1, but that one there would also yield a 0 and a 1. So for each one of those, so yeah, and then we've got a sort of tree branching-y structure kind of plugging in here as we go along. The input contains very few x's, yeah, but where's the fun in solving for simple cases? So what I'm kind of thinking we want to do is something like for var first bit in fuzz mask mask dot 0. So take the first bit of the mask and address. But the thing is, the address here we need to do a which direction do we need to do a bit shift in? Because we want to bit shift bigwards. um, binary left shift is what we want here, I think. That by the number of, discards the high order bits that are outside and sets the low order bits empty equivalent to, no, that's not really what we want either. We want to shunt it that way. So we need to be looking at we need to look at the mask from the other end. So if mask length is 1, then that's absolutely fine. Otherwise, the address, we want to shift that way by 1 bit, which means that we are gonna take the... Yeah, go from the high mask bits, it's easier as you can shift... Yeah, but if we shift left... Actually, yeah, if we shift left, it doesn't matter. We don't need to know the... okay. Right. Time for another little think. Okay. Mask looks like this. 1x 0. We want to look at it. We want to look, okay, so this is our, and then our input for this is going to be the bits 1, 1, 1. Okay, so that's the mask. That's the input. So, we want to look, mask character number 1 always overwrites. So mask 1 means we want to chop off this bit here, and our solution space always going to start with a 1. Alright, move on, have a look at the next one here. Now to do that, for the mask, we can take a substring, and for the input, we want to do a left shift. So that effectively means we are now looking at, this thing is gone, we are now looking at that thing, but this number 1 here that we got off that bit needs to be put into our accumulator somewhere, okay? So we got as far as that. Now the next step, we want to look at that. Now we've got an x. Now that x says we need to yield both of the possible values. So that's going to be a 0 and a 1. And now again we do a substring and we do a left shift. Now we look at a 0. Now the 0 says that we always return what we had, which is going to be a 1 in this instance. So that's a 1, that's a 1. And at this point we shift again, and now there is nothing in the mask. So at that point, now what's the recursive case here that we use to break this stuff back out? Because we need to, yeah, left shifting is easier because we're always looking at the last bit there. So we are always going to be saying, yeah. Mask length 1 is our degenerate case. Mask length 2, we need to say, for each candidate. So for each, so at that point, we're looking at, so that one's there, that one's there, that one's, we're down to here. We've got our 1s, so mask 1 says for each prefix in fuzz mask, thank you, fuzz mask, so at this point we want mask.substring from start index 1, and we want address by left shift 1. So that's going to give us these two possible ones. So for that 0 here, so that for each is going to loop around this thing. So for each one of those, if I got a 0, I want to yield return the that plus that, that plus that. So, um, ah, fuzz mask. Shift that left. That's fine. That gives us that. Shift that left. That's fine. Shift left. That gives us that. I need to yield return. Now, this is the fun part, is what do I combine with each of those prefixes to give me no. I think we need to do it like this. The base case here is if mask.length equals 0, we yield break. Otherwise, we want to switch on mask length is 0, yield break. Empty mask returns no possible values. Otherwise, okay, so I'm going to put in a long options here. If this is an X, then options equals new 0 and 1. If case is naught, then options equals this. And case 1, options equals that. So what I've got is, depending on what the thing is at the top of my stack, or at the beginning of my input, break, thank you, break, thank you, break, thank you. Why is that complaining? 1L. Address and 1. Yeah, that's fine. 0L, 1L. Okay. Okay, so that gives us the options that we get for this one. And then I want to say for each var origin for option in options, for each var, I'm going to call this to make it easier and skip the left shift, we can use binary code as string form. I think the left shift is actually going to do it. For var prefix in options, use of unassigned local variable long options equals new long, so that will initialize to be an empty set of longs. Spin that around to var, that's fine. Take that out, that's alright. So for each var suffix in fuzz mask, and at this point we say mask.substring of 1 and address that one. Yield return. So at this point we need to shift the prefix back the other way. And do a bitwise OR on it, I think is what we want to do. Bitwise OR, there, boom. Everything broken. Why is everything broken? Because if mask length 0 yield break, if that is that for each suffix in that. There. Right. So base cases are no longer working. Why not? Let me go and grab one of these test cases. That's fine. 6 failures. All right, and that is breaking. So let's say when we feed in a 0, 0, and that one. So mask is 0. Mask length is not 0. Yield break. Switch on mask 0. That one looks fine. That yield break is not doing the thing that I want it to do. I think we do need the, if mask.length equals 1, this is very, very interesting. So, right. Break this thing down again. Mask 0, break, that's fine. If, yes. Recursion slowly melts man's brain. Live! You saw it here on Twitch TV. That's why some people have music on these streams, you know. So I do actually have I had the Twitch soundtrack thing installed in here somewhere. Maybe that's one we can play with on the stream later. Right, where were we? So let's break this down in. First, I'm going to do 1 input, then I'm going to do 2 inputs, then I'm going to do 3 inputs, and then I'm going to figure out how to make the damn thing recurse properly. So let's have a look at, so if our mask 0 is x, then we need to return a 0 followed by options for the rest of mask, and we need to return a 1 followed by options for the rest of mask. Yep. If it is a 0, we need to return a that followed by options for the rest of the mask. Yep, so that's that. That's that for each of our prefix in options. Now this is the thing here. For each suffix, when this does a yield break, that gives us nothing. And so that doesn't give us anything because it has basically we get a whole bunch of trees that all go, oh yeah, there is nothing at the end of this. The yield break in there, when we hit one of those, nothing's going to happen. We ain't getting anything out of it. So I think that our base case here, because we're using enumerators, our enumerables needs to be the mask length is 1. because I don't see how the base case can be combined back into anything using iterators. So if mask length equals 1, I'm going to go back to what we were doing before. If you shift the suffix right for a single bit is always 0. Yeah, it is. So if mask length equals 1, let me just, I'm going to plug this lot back in. So on that, we want to switch on mask 0, and if it's case X, we want to yield return 0, yield return 1, break. I like that. To me, that kind of feels like something that we want to do here. And case 0, that is going to yield return just that. And then break. And case 1, we want to yield return, what was it? It's always 1. And the 1 is a long. And now it's saying that you don't need to specify. Oh, it needs to be a big L. All right, that's fine. We like that. Cool. Okay. So there's that. If mask length equals that, then hang on. Mask length equals 1. There was that. Otherwise, for each suffix in fuzz mask substring 1 and address shifted by 1, yep, so that should give us add a whole bunch of stuff. That's fine. Mask length equals 1. Yield return that. So that's going to give us so we got a prefix bit and we've got a suffix bit. I think we need to do this. I think what we need to say is that prefixes needs to be a collection here, because we need to be able to use it or return it, I think. So case X prefixes equals 0, 1. Yeah, those can go. That should be fine. Break. Okay. Replace assignment. Okay, there's that one. And switch section. Nope, that's fine. That's not what I want. That's not what I want. List long prefixes. Prefixes equals that. Yep, that's alright. That's alright. Prefixes equals new list long. I'm sure the syntax for this can be cleaned up, but I'm just trying to get the shape of the recursion thing right first. So, and I don't want a line there because that's going to break that out. So there's that, there's that, there's that, there's that. If mask length equals 1 for each of our prefix in prefixes, yield return prefix. Might not be initialized. Okay, fine. You can have your There we go, that's fine. For each prefix, if mask length is 1, give it back. Otherwise, this is looking promising. This is looking promising. So I want to shift that and bitwise all that with the suffix. There we go. Right. Plug in a couple more test cases here. So we are also expecting to see a... So if our input is gonna be so let's run the two cases. So we got mask 0, 0. So let's say that our input here is gonna be, what's 2 bits number? 3. So 3, 0, 0. That should preserve both possible values. We should have the output 3, correct? Let me just bring that way down there. 3, 0, 0 should be 3L. Why is that breaking? I don't know. Let me bring this up to where I can see what's actually happening with it. Ncrunch is definitely more comfortable being vertical. Sling that in over there. So that test there is failing. Why is it failing? Let's just bring that across a little bit. Should be 3L, but was 2L. Why is the difference there? So, alright, we got 2 bits. That potentially gives us... 0, 0, 0, 0. So 0, 0, 0, 1. 1, 0. 1, 1. And then we've got 0, x. We've got 1x. We got x1. We got x0. We got x1. And we've got xx, right? So now if it is 0, 0, the rules for the bit mask say that it should preserve all values on the input. Where's the Advent of Code webpage gone? It's not that one. It's not that one. It's that one. 0, the corresponding memory address is unchanged, so it fuzzes nothing. 1 always overwrites with 1. So any input with 1, 1 should give us a 3 as an output. 0, 1, 2, 3. Zeros should always preserve the input, so... Zero should give us 0, 1, 2, 3. A 1 always overwrites. Address is always overwritten with a 1. Oh, look, we have a comment from Interesting Content Productions. Hello, Interesting Content Productions. Interesting Content Productions was my mother's name, you know. How you doing? So we've got shift address first, shift address left. After the first iteration, it will be always 0 with right shift. Shift address left. Hang on. I just want to flesh out the rest of these test cases for the 3-bit scenario. So, or the 2-bit mask scenario. So, if it is a 0 and a 1, 1, it should always be 3 because that will always be overridden. Now, 3 and a 0x, the 0 is going to preserve the input. So the potential outputs we've got here should be 1, 0 and 1, 1. So it should be that. A 1 and an x will always override it. So it should be a 1, 0 and a 1, 1. So it should be that one. Fuzzing on the x will give us a 0, 0, and it'll give us a 1, 0, which is 2. Fuzzing on that one will give us a 1, 1, or a 0, 1, and a 1, 1, which is 1 and 3. Fuzzing on the XX should give us 0, 1, 2, and 3. Those are the values that we should be expecting out of these set of inputs here. So, and that is, let me just see very briefly, tools, extensions, NCrunch, options, configuration. Yeah, that's fine. Zero preserve, so 0x, yeah, 0x would be 0, 0, 1, 1. I just want to very quickly see if text output font, yeah, that one there, I want that to be different. I would like that to be Fira code, please, and I would like it to be a little larger for the folks watching at home, please. There we go, look at that. You should be able to read what's going on now. So, 0 preserve 0x, so 0x would be 1, 0, and 1, 1, which is, yeah, is 2 and it's 3, is correct. Yeah, that's fine. Let's go back to Adam's comment. Shift address left. After the first iteration, it will always be 0 with a right shift. So, shift address left. Where is address being shifted? Here, address is being shifted left. That's what we're doing when we do the recursive deep dive case. We're looking at the x0 case. Yeah, x0 is here. So if the input is 3, that's, oh, hang on, that's not correct. 3 with the x0. 0 is preserve. So and if the input is 3, 3 in this is a 1, 1. So x0, so that should actually be x0. The 0 will preserve it, so the 3 will get a 0, 1, which is 1, and it'll get a 1, 1, which is 3. Let me just, I'm going to go through these test cases one more time. So a 0, 0 preserves its input. 0, 1, 2, 3. That should all be fine. And let me just comment out a whole bunch of these cases and build it up in steps. Okay, so 0, 0 is not working properly. 0, 0 is not preserving input. So let me have a look at what we got here. Yep, so 0, 0 doesn't work. If that's 0, prefixes equals a new list of long address. Bitwise ANDed with 1 is... yeah, that should, so a 0 bitwise AND with 1 is a 0. A 1 and 1 is 1. So that should always preserve whatever the least significant bit of the input is, correct? So if the mask length is 1, yield return the prefix. We know that that's working because we've run the numbers here. All of these single digit cases work correctly. Otherwise, it's just, I think, a question of, maybe it's to do with binding precedence. No, it's not. All right. So for each suffix in, so mask.substring1 and address here is left shifted by, that needs to go that way. No, it doesn't. It does need to go that way. But no, that's not right either, because the address left shifted by 1 is going to leave the least significant bit of that is then always going to get set to a 0, because left shifting always pads in with the zeros. So the problem I've got is, no, I need to, this thing here needs to preserve the most significant bit of the address, not the least significant bit. How the hell do you do that? Because we don't know how long the input is, so yeah, no, I get you now, Adam. It's we need to flip the whole thing backwards, don't we? So that one, the address, we want to right shift it every time. We need to iterate the masks from the left, which means that the mask.substring, we actually need to take, instead of removing the first character, we need to remove the last character of the mask, which I'm sure .NET remove last character from string. So the length of the address is kind of insignificant because we're using 64-bit integers with 34-bit masks. Remove has to remove new string with all characters beginning at a specified position. Man, I one of the things that I can, yeah, continue with cookies, whatever. One of the things I wish that C# did more nicely is a way of just removing the last character instead of having to do string.length -1. Just strikes me as a slightly clunky way of doing it. Yeah, alright, so we're going to have to do that. Ooh. Ooh, that's interesting. In C#8, ranges and indices were introduced. Succinct index, so that gives us a whole bunch of things, but that only works on arrays, I'm guessing. Yep, alright, okay. So, else, so let's do a trimmed mask. Oh yeah, we could just make it an array, couldn't we? What was that cool thing I just found? Back that up. Forward that. That's nice. Indices and ranges. So index from start, index from end. Boom. So I want 1, 2. Okay, so I think let me just do a var trimmed mask equals that. Trimmed mask address yield return prefix on that. Now the interesting question now is, has anything gone into an infinite loop? The End index word 0, dog 8, that's 1. Yep, yep, yep. So maybe, just maybe, let me try putting a 2 on that. See if anything runs. No. Okay. Interesting. So let me find that's, and then right. Cannot convert from string to char. Oh, come on. You can do that. You know how to do that. Overloads. Index was outside the bounds of the array. Musca.cs line 28. So this is where we need a thing that says what's our case, our base case here? So if mask.length is 1, return prefix. So that call there, trimmed mask, mask from, that should be 0 through to there, shouldn't it? And that can come out there. Do I have a C# interactive environment on here? Let's have a look. View, Windows, 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 other Windows, other Windows. Where is it? There it is. So we've got foo.toChar array is that, and if I go foo, actually let's do ABCDE because foo is a bad word for this. .toChar array. How the hell do I add things to the the C# interactive window? Because using doesn't work. I love it when they give you nice shiny features, but those shiny features then do not do the thing that you think they should be able to do. Let's go back to what we were doing. So 1, 2, 3, 4. So back to our little naughty program so we can try this thing out. Scrub that we were playing around with earlier. Grab that, grab that, grab that. Format that. That's nice. And I want to drop in a thing here that says ABCDE dot to char array substrate on that and doing 1. So console dot right line of that lot. Boom. Back over to the terminal window, .NET run on that thing, see what we get out of it. It's going to say ABCD. Okay, so that does indeed, .bing1 does remove the last element from the array. So trimmed mask is now returning the mask with the last element removed. So fuzz mask is now doing a thing there. So let's go on here and just console.writeLine suffix. And now I should get some. Alright, so and I'm going to stick a breakpoint on there. So for each var suffix, yield return prefix dot suffix. So for each prefix, for each suffix, all I need to do now is figure out, are we gluing these things together in the right order? But of course the prefixes are no longer prefixes because we are looking at the wrong end of the mask. Yep. That's all right. That's all right. That's all right. So I want to go in here and I want to debug one of these test cases. So what was our test case here? Let's just have a look at the so 0, 0 here. This is not working properly, so I'm going to debug that. Actually, I'm going to drop in a breakpoint on here. There we go. That's nice and ding. And I'm going to restart that. Stop that. Nope, that's fine. Right click, debug selected test. Okay. So what do we got here? Our mask is 0, 0. Our address is 1. Our prefixes is empty. The mask of that thing is 0. That is correct. The address is 1. Address and 1 is equal to 1, which is correct. Plug that into prefixes and break. Then for each prefix, if mask.length equals 1, no. Otherwise, so what is trimmed mask now? Trimmed mask is 0, yes. And address shifted by 1 will be 0. Yep. That's fine. That's fine. If mask length equals 1, return the prefix. Yep. That balls us out of that. So now we have a prefix and we have a suffix, and a prefix left shifted 1 is gonna give us what? No, don't worry about stepping into that. That's fine. Should be 1, but was 2. Which makes me wonder, again, if one of my test cases is not coming out correct. Let me sling that back over there so we can look at it. So, multiple processes. Let me just debug. Stop debugging. That's fine. No, don't crash. Come on, Visual Studio. You can do it. Well, this is exciting. Haven't had a good Visual Studio crash in a little while. What are you trying to do? No, stop now. Yeah, stop now. Come on. Look, it gives you a stop button that you can't click. There we go. If you shift the prefixes left, you need to iterate mask from left, not right. Okay, thank you. That's nice. So let's just check. So we are shifting. So let's just take a look at what it is that we're actually doing here. So we've got a mask and we got an address, and the mask looks like 0x1, and the address is an integer which is like 010. So the first thing that we are doing is we are looking at this thing here. We're looking at mask of the 1, like inverse 1, which is the last element in that mask, which is this one here. So we are looking at that element there. We are switching based on that. If this one is case 1, then our prefixes becomes a new list of 1, L, which is fine. And then for each prefix in prefixes, so for that number 1 there, what I want to do is, if our mask length is 1, return it. We know that that's working. Otherwise, we need to trim the mask, which means take everything else. So take this chunk here and look at these two numbers here, which means the shifting the, yeah, it should be shifting the address right. Because shifting the address right, what that's going to do, this number will go missing. So it will effectively give us a 0 on there, and that will become our new input, I think. But hang on. So prefix and suffix have ended up backwards. So I'm just going to replace this with suffixes. Okay, so that's fine. So I'm just going to replace for var, that one can now be ptemp. Prefix is going to be suffix, and ptemp is going to become prefix. You shift your value left, yeah. This thing down here is incorrect now. You shift your value left. Which line are you talking about, Adam? You're talking about this thing here, line 47. Because there will now be a brief pause while we wait for the YouTube latency to catch up. So I'm actually gonna completely rename this thing, because what we are doing is when we put this thing back together, we've got that number already, and then that one, and then that one, and then that one. So that there is actually gonna be our Triller code. There we go. Sorry, yeah. And let me just shrink the test window there. I think it's this line here is putting things back together in the wrong order. So fuzz mask, trimmed mask, address right shifted by 1. That gives us the right thing. That gives us the right thing. But then for each one of those, we want to yield return. We want to shift the prefix by 1 that way, and then bitwise all that with the suffix that we got out of what we want. Look at that. Boom. You see all those little green lights down the side of the screen? See that? You see that? See that? That means all the things. So now let me go back into our unit test cases, and let me just uncomment that, save that. What do we got? Yep, everything's still green. Uncomment that lot. What do we got? Everything's green. Uncomment that lot. What do we got? Everything's green. I cannot honestly now be, no. So what happened there is when we switched from doing kind of big endian to little endian, I forgot to switch around the order that we were sticking the things back together at the point where we turned the thing inside out. So I'm going to put that back in there and get rid of that, because I don't like that very much. Okay, so let's go back to our program. What were we doing before we were so entertainingly diverted? Yep, that's all fine. So what we need to do now is run the program, and this program, just every instruction just like mashes the crap out of all of our available memory, right? So let's just try it on the test program here. So there's that one. And that should be 208. So we're expecting a 208 out of our dummy input here. So I'm gonna split that one out again. Var input equals. So copy that into there. That one becomes input dot yada dot yada dot yada. That's all fine, but I can take that line out. I've got a. What was the program here? Mask 42, mask 26. Paste that in there. That's private const on that. That's all fine. Drop those back. So now the logic of our program now is if we read a new mask, that's fine. Otherwise, this is no longer correct, because this is the value, that thing comes out because that was the solution to part 1. We want to say for each var memory address in masker.fuzzmask, and this is gonna fuzz mask memory address. Hang on. We still need that. And the value is just value now, isn't it? Because we're not doing anything funny with that, because this does not modify any of those. And now we just need to make our computer big. I love the fact that it took reality, like to go from computers with 32-bit address space to 64-bit address space. Took pretty much, so the first 32-bit computer I ever had was a 386SX in about 1992, and the first 64-bit computer that I had would have been a, what was the first thing? Probably a Core Duo. So it took 20 years, and we just did it by replacing that int with a long to go from 32 bits to 64 bits of address space. So we're expecting now, if I run that on the test input we've got here, and again it wants the sum of all values left in memory, this test case should give us 208 if I've wired all the pieces incorrectly. Take that breakpoint out, continue running it, and it's given us 8. It's given us the value 8. That's probably not the correct answer. Curious. Why not? So just to check, that mask there should give us 8 memory addresses, right? I'm just going to throw in a couple more tests. Just a couple of little bits and pieces. Test case 8 and that. Public void count fuzzes. So there's that one, and we've got, so what is it? Int address, a string mask, int count. Var masks, var addresses equals masker dot fuzz mask for that mask and address. Addresses dot to list dot count dot should be count. All right, so that appears to have done the correct thing. Let me just check another one. So 42 plus this mask should yield 4. So let's plug in a test case. 42 plus this mask should yield 4. Okay. (16, 17, 18, 19, 24, 25, 26, 27). Let me throw in one more case on here. So test case of 26 on that array there should yield a new long of 16, 17, 18, 19, 24, 25, 26, 27. Okay, my input is mask equals mask equals. Thank you, Lars. Much appreciated. 208. All right. You know what that means? That means it's YOLO time. Chop that lot out. Plug that lot in. And away we go. Look at that. It's a number. Sweet. I love it when a plan comes together. Right. I just want to. So that's the correct answer. That's what we got. That's kind of nice. Now I just want to take another 2 minutes because I want to just have a look at that algorithm that we got here. Because I think we can do something more entertaining with it. All right, I think we can make it. So, basically, I want to make this into the most, like, excruciatingly unreadable, tiny, tiny little succinct block of code. Now, what I'm wondering is there a nice way of... So this new list long stuff is very, very... I just want to look at all the different things we can do with Switch and C#. Latest versions, what we can do in it. Actually, we can do it in see, what I'd love to be able to do is something like var suffixes equals switch mask 1 case that, and just have a yeah. What's the new expression syntax? What's the expression syntax that I'm looking at? I've seen stuff that is kind of making me think there's a nicer way of doing this. If you've got a link to the thing you're thinking of, Sanai, I will definitely take a look, because I'm sure there is a nicer way of doing what we're trying to do here. But I just cannot think what it is likely to be. Init only setters, no. Ooh, I tell you what we might be able to do. This will be fun. We can't return enumerables from inside other enumerables. It might be that. Hang on, Eric. Let me have a look. C#8 switch statement. Yes. Yeah, that's what we want. Var suffixes equals Oh, this is nice. Do we want to just plug in a default here? Right, we'll come back to that in a second. I'm trying to think which one of those would make the most sensible default. And probably that one. So let's throw that in there. That's fine. Right, that's got that down a little further. I'm sure there was a way in no, because I'm trying to default through your that would be sensible, but I'm trying to fit it into the tiniest number of lines of code possible. I'm sure there is a way in enumerables to return if you've got an enumerable inside an enumerable. Yield return nested enumerable C#. For each something in something, yield return something. Yield return something, yield return, yield a nested enumerable. Yield return, yep. No, that's not what I want. That's not what I want. That's not what I want. Nope. Oh, for the time zones thing test. Yeah. Weird that there isn't a for each on thingy. I'm having one of those moments. I'm like, there is definitely a enumerable dot for each in C#. It only exists on the list. It only exists on the list. Okay, that's why that doesn't work. Now the question is doing this in enumerables better or worse than just doing it with a list? So let's just check. Right. That works. Hello, Chris. This is part two, and it's done. We're just trying to make it interesting. I think. I'm gonna throw this to GitHub. Then I'm gonna take the enumerables out, replace them with lists, because I think by replacing them with lists, I can bring the whole thing down by another 2 or 3 lines of code. And after all, that's what we're here for, right? cd.cd github cd advent of code git add dot git commit minus m solved day 14 using yield return inside a recursions using recursive yield returns. Yay. Okay. You see, I reckon if I say this is now just an I list of long instead of an I enumerable, if mask.length equals 1, so at this point I can say return suffixes. So we don't need the nested thing in there. Ooh. Maybe. Hang on. So if mask length equals 1, return suffix is else return suffix is dot select suffix goes to now that's going to complain because I can't return a thing from a thing, but this could still be an I enumerable. Now, why is that complaining? That's complaining because cannot convert systems to direct an I enumerable of system.collections because that needs to be a select many. There we go. That's got that even smaller. And I'm sure it can go smaller still. So first of all, no. Let's rename that one to tails and return that one to tail and return prefix to head because that looks a little bit cleaner. That goes to that, that's fine. Yeah, a little bit of code golf, why not? And I could make this Let's make that address. That's slightly better. Yeah, that'll do. I still wish there was some way that we didn't have to have the new list long repeated 3 times in here. Maybe. Actually, this might be a fun one to stick on Twitter or something and see if Skeet can get it any smaller. He may enjoy that. Anything we can do to get this smaller? Anything that's been... Yep, alright. I am going to wrap it up because I've just found out that they are closing all the pubs in London again on Wednesday at the stroke of midnight, which means if I want to go to the pub again in 2020, I have to go tonight or tomorrow, so I'm probably going to go to the pub. Thank you for tuning in, friends. That was cool. Today was fun. Like the assignment was kind of interesting. It made a lot of sense, but it was really nice. Like there is so much cool new C# stuff in this. I tuned into someone else's stream earlier today, and they're trying to do it in a different language for every day. Um, and I love that idea, but I sort of I have questions about the kind of person who goes on a live stream to try and do advent of code in a language they've never used before. They give it 2 hours and they start talking about how the language is a piece of crap that doesn't make sense. And you're like, well, it doesn't make sense to you because you've only been doing it for 2 hours. But there is some very, very nice stuff here. This is extremely... Ooh, hang on. I think I might have worked out a way of making it squishier. Look at this, look at this. Fewer characters. Let's golf this thing. Ah, look at that. We can take the L's, the longs out by making the literals even smaller. Do it in Clojure. Clojure is it's a Lisp dialect that compiles to the JVM, right? All right, I can do one in Clojure one day. So you got to realize I'm on something of a streak here because every single day so far I've solved both parts live. So if we get one day where like parts 1 and 2 are both done inside of half an hour, at that point I'll be like, let's try and do this in Clojure. But what I don't want to do is to start the stream in something like Clojure, get an hour and a half in, make no progress whatsoever, and then be like, I don't want to break my streak. Because it's not a competition, but it is... I think the day I fail to do this will be the day I don't bother coming back tomorrow. Because so far it's just kind of the sticking on and the tenacity of going every day. We get this thing done live, so I never have to come back and go, oh, first I got to do yesterday's. That's what killed it for me last year, is being like, oh, I'm 2 days behind, so to catch up I need to solve 3 days in one go. So yeah, I don't want to do anything which is potentially gonna mess up what I'm doing. Right, the last thing that I want to do here is just let me go over here. Yeah, the parser here could be a little bit more interesting, couldn't it? But never mind. That's nice. That's nice. Okay, cool. Right. We need a target. We are going to raid somebody. Let us go onto the intertwitches and see who it is who is gonna be the recipient of all of you lovely fine viewers. And we've got Layla was online earlier. I think Layla's probably wrapped it up. Who we got here? I develop things as bug fixing. Let's have a look who we got. Any nominations? Anyone want to pick someone we can all go and raid en masse? Otherwise, we'll raid I develop things and call it a day. Let's do that. Oh, and those of you watching on YouTube, we're on Twitch where we have raids. So let's check. Is this going to do the thing we want to do? Yeah, let me just... Oh, hang on. I've typed the wrong thing into the wrong window. This is never going to work. That's... Oh, hang on. There's someone doing Advent of Code in Haskell over here. Yeah, that'll do. We're going to raid Tritlo again. All right. Thank you for tuning in, friends. A lot of fun. I will be back tomorrow with some more. Take it easy.